Alright, today we are looking at some physics dealing with calculus. And what we want to look at here is mainly what we can do with the derivative function. First of all, we're given displacement, velocity, or acceleration. Those are the things that we're going to be dealing with. Displacement, just how far away you are from where you started. Velocity, how fast you're going with direction. So if you're going backwards, you should have a negative velocity. Acceleration, how fast you are speeding up or slowing down, how fast velocity is increasing or decreasing. The main thing is what we're going to look at is that velocity is the derivative of displacement, and acceleration is the derivative of velocity. So if we're given a displacement function, we can take its derivative, find the velocity. We can take the derivative of that and then find an acceleration function as well. So some examples that we ended up doing, let's say we had a displacement function d of x equal 20x cubed. I wanted to know the velocity of the ball at any given time. Well, the velocity is just the derivative of the displacement function. So that makes it, in this case, 60x squared. If I want to find acceleration, well, that's the derivative of the velocity function, or the second derivative of the displacement function, which in this case would be 120x. Now, something else I can look at here is, let's say I wanted to find what the exact velocity was at time equals 1. Well, literally all I do is I plug in 1 for that velocity function. So 60 times 1 squared, which is just 60. I can do the same thing. What if I want to know the acceleration at time equals 2? I'm just going to plug in 2, 120 times 2, which would equal 240. And normally we'll deal with units. Normally it's going to be in feet per second or inches per second or maybe miles per hour. Normally it'll give it to you based on the context of the problem. So we'll say in this case this would be feet per second and this would be feet per square second. Something like that. Okay, another thing we wanted to look at though was average velocity. So a ball is dropped from a height of 100 feet, displacement given as such. To find average velocity, the average velocity, all we're going to do is we need to look at the change in displacement over the change in time. So we want to go from t equals 1 to t equals 2. So we want to look, okay, what was it at 2? What place, where was it? Same thing for time equals 1. What is the displacement? Over the time, 2 minus 1. So all that we will do is plug in for each individual one. So when time equals 2, we're going to have 16 times 4, which would be 64, negative 64, plus 100. So 36 minus, when I plug in 1, I should have 84 all over 1. When I do that subtraction, what should I end up getting? I should have, figure it out, negative, 48? And again, we'll say probably feet per second. Now, just for comparison, if I wanted to say the instantaneous velocity, so at time equals 1 and at time equals 2, I'm just going to take the derivative. Well, the derivative of this function is going to be negative 32t, just based on doing the derivative of s of t. So when I plug in for that, I should have negative 32 feet squared, or feet per second, for time equals 1. And at time equals 2, I should have negative 64 feet per second. So it should make sense that this average velocity is somewhere in between the two instantaneous velocities. And one final example that we did, a diver jumping into a pool. First question they said, when does he hit the water? So hitting the water, that's dealing with just displacement. How far away from the water is he? So we're dealing with displacement in this one. And while we're solving this, we should be thinking, okay, do I want displacement, velocity, acceleration, etc. So if the displacement is 32 to start, which is what it's going to be in our original equation, because when time equals 0, we're at 32 in the air, me about to jump off. So I need to see when I hit the water, that means my distance is 0. My displacement, is 0. So I should say, when is 0 equal to s of t? When is 0 equal to negative 16t squared plus 16t plus 32? Well, I can factor here, and try to find out exactly when that would be. Factor out a negative 16, I get t squared minus t minus 2. If I reverse FOIL to factor it, I should get t plus 1 and t minus 2. That means t can equal either negative 1 or positive 2. Well, when would this make sense? Would it ever make sense to us for us to have a negative time? No. So we're going to ignore that one and say he's going to hit the water at t equals 2. 2 seconds, we'll say. Now the second part of this problem is going to be, what is his velocity when he hits the water? So what we want to know at t equals 2, we need to find the velocity function first, which we do by taking the derivative of s of t. So we want to say it's s prime of t, and that's going to equal negative 32t plus 16. So if I want to find his velocity at that time, I want to look at what v of 2 is. So I'm just going to plug in negative 32 times 2 plus 16. So negative 64 plus 16. So it should be a negative 48. And again, this is velocity now, so we should want feet per second in this case. And that's how you do problems dealing with acceleration and velocity and displacement here in calculus.